All right, this is the 2023 BC exam number 6. So this is the Taylor series problem. So we're given a function f that has derivatives of all orders for all real numbers. We have a value for the function, the first derivative, the second derivative, and an equation for the third derivative. They want us to find the fourth derivative, then write the fourth degree Taylor polynomial centered at 0. Okay, so let's go over there and start this out. Okay, so we know it's centered at 0 because that's where all of our information is. So f of 0 is equal to 2. They told us f prime of 0 is equal to 3. So they told us f double prime of 0 is equal to negative f of x squared, which would be negative f of 0, which would be negative 2. So next thing is we have the third derivative. They've also given us some information about the third derivative. It is given negative 2x times f prime of x squared. So we know for r's, if we were doing the third derivative at 0, I believe that's going to be 0 because we're going to put 0 right here and it's going to multiply to 0, so that term is now gone. And now we need the fourth derivative. Okay, so notice that we're going to have to do the product rule here to find the fourth derivative. So the fourth derivative is going to be the derivative of the first piece, copy down the second piece, plus the derivative of the second piece, the chain rule, copy down the first piece, and again we're going to plug in 0. So the fourth derivative at 0 would be negative 2 times the first derivative at 0, which is 3. And this will zero out over here, so this is negative 6. So this is our constant. Constant, that's not a constant, that's x. So this piece is our constant, this piece is our linear term, this right here is our quadratic term, cubic term, and then quartic term. So the next thing it wanted us to do was actually write out the Taylor polynomial. So remember, the Taylor polynomial forms are, so if we wanted the P4 Taylor polynomial, it would be f at 0, f prime at 0, x. The second derivative, the second power, the second factorial. The third derivative, the third power, the third factorial. The fourth derivative, the fourth power, the fourth factorial. And now we fill everything in. F of 0 we found to be 2. F prime of 0 is 3. F double prime of 0 was negative 2. So negative 2 divided by 2, the 2's cancel. The third derivative is 0, so that one's completely gone. And the fourth derivative is going to be negative 6 over 4 factorial. So that's going to be negative 6, 4 times 3 factorial, so that leaves us with negative 1/4. So x to the fourth over 4. So there's our P4 Taylor polynomial. I'm going to take this and I'm going to copy it and move it to the next slide. So A is worth 4 points. You get 1 for the form of the product rule here. You get 1 point for getting f of 4 correct. You get 1 point for the first 2 terms of the Taylor polynomial. And you get 2 points for 1 point for the next 2 terms of the polynomial. So heavily weighted on taking that product rule correctly. And it was difficult. There's product rule and chain rule in there. All right, so the next problem is asking, part B, is asking for us to, given the fourth degree Taylor polynomial for f is used to approximate f of 0.1, given that the fifth derivative is less than or equal to 15, between where it's centered and evaluated, use the Lagrange error bound to show that this approximation is with 1 over 10 to the fifth from the exact value. So what we're looking for is the Lagrange error. So remember, the Lagrange error is basically the next term maximized. So let's go ahead and write the next term. Well, that was a degree 4, so we're going to look at degree 5. So the fifth degree, and then we know we had x minus c, so we're evaluating that 0.01 to the fifth over 5 factorial. And what we need to do is maximize that derivative between where it's centered and where it's evaluated. Now notice they gave us that. They told us that the max was 15. So I know this is less than or equal to, and I could put 15 here. And then of course we have 0.1 to the fifth over 5 factorial. So I got to kind of manipulate this to show that it's less than 1 over 10 to the fifth. But if you look at this, it's going to be 15 over 5 factorial. This is the same thing as 1/10, so 1 over 10 to the fifth. 5 factorial is 120, so 15, 120 times 10 to the fifth, that's definitely less than the threshold they wanted. So there's your Lagrange error for this problem. Part B. You're going to get 1 for the form of the error bound, and 1 you're going to really show that this is less than 1 over 10 to the fifth. Part C. Let g be a function such that g is 0 is equal to 4, and g prime is equal to e to the x times f of x. Write the second degree Taylor polynomial for x, for g about x. All right, so we have a couple things. We've already calculated f of x, so let me go grab that again. So there's our polynomial for f. And we're going to take this polynomial and we're going to need to multiply it by e to the x, because they've told us that g prime is equal to e to the x times f of x. So let's see. Here is our f of x. And again, this goes on forever. And we need to multiply that by e to the x. And again, that goes on forever. And this is going to be equal to g prime. Well, I can't multiply an infinite polynomial by an infinite polynomial. So what I'm going to do is only multiply term by term and looking at certain things. So the first thing I'm going to ask is how many ways can we get a constant? I think the only way we can get a constant is multiplying the first term by the first term over there. So the first part is 2. The next thing I look for is how many different ways can we get a linear? So I'm going to go through and figure out how we could get our linears. So if I take 2 and multiply it by x, that will give us a linear with a coefficient of 2 in front. If I take 3x and multiply it by 1, I get a linear. The coefficient would be 3. And it said second degree. I'm going to go ahead and do one more. So the next thing, let's see, we want to do is our quadratic terms. So if I take this and multiply it over here, that's going to give our first quadratic term, which is 2 over 2 factorial, or 1. If we take 3 to the x and multiply it by x, you're going to get a quadratic. So plus 3. And then lastly, if I multiply minus x squared plus 1, I'm going to get a quadratic. So now we know our g prime is equal to 2 plus 5x plus 3x squared. Now we really want to get to g. So what do we do to g prime in order to get to g? We're going to integrate both sides. So as I integrate both sides, now on the left we're going to have g. 2x plus 5 halves x squared. That's the quadratic they wanted. They wanted a second degree, so I don't have to go any further. But remember, I have to pick up a plus c because of the constant of integration. But they told us the constant is 4. G at 0 is equal to 4. And you see if I plug in 0 here, I plug in 0 here, you're going to get G is equal to 4. So this is your approximating polynomial for G to the X. Okay, so next thing we need to do is look at the point allocation. These were 3 points. One for showing the multiplication of these. Now there was another way to do the problem by taking all the derivatives of g of x instead of multiplying it. So I could have found g double prime, g triple prime by doing product rules and stuff. I chose to multiply it because it was a pretty easy process. The next point comes from the first 2 terms of this Taylor polynomial, and the next one is for getting all 3 correct.